This video is for class 9 physics, and in this video we are discussing about potential difference and resistance from the chapter current electricity. Now from our previous knowledge of charges, okay, we know where the charges comes in case of wires, right? So the flow of electrons, we need to understand the flow of electrons between the conductors, right, between the conductors. So when two charge, I hope you know what are conductors, those who can carry current, right, those who have more number of free electrons. So when two charged conductors are joined by a metallic wire or they are placed in a contact, free electrons flow from a conductor having higher concentration of electrons to the conductor having lower concentration of electrons. We have studied this, right, when we were studying current, right. So the movement of electrons stop when the concentration of electrons in both becomes equal. This can be understood by the following example. Now the first example here, we have positively charged conductor, right, connected with one uncharged conductor. So what should happen? This positive charge should attract the negative charges. So any free electrons moving on the surface of this particular uncharged conductor will get attracted towards the positive charge. So the direction of the flow of electrons will be from uncharged conductor to the positively charged conductor, right. So electrons moves from charged conductor uncharged conductor to a charged conductor, because here the charged conductor is positively charged. So this movement of electrons continues till both the conductors have equal concentration of electrons. That means in both the conductors, if they become neutral, right, then the electron stops moving. In the second case, which is shown in figure 9.19 here, we have a negatively charged conductor. We have one negatively charged conductor here, this one, right, which is connected with the uncharged conductor with the help of a metal wire. Now this here is charged and it has negative charge because of the more number of electrons. So what will happen, since we are learning the direction of flow of electrons, so the electrons will flow from charged body to the uncharged conductor, unlike before, right. So it will continue till all the electrons between those two conductors becomes equal, or all the excess electrons from A will reach B. It will continue till that point. Now this movement of electrons stops when both the conductors acquire equal concentration of electrons. That means both of them should become neutral. Thus coming to the next example to understand the flow of electrons. Now what we have two charged conductors, one with the negative charge shown here. A is the negatively charged conductor and B is positively charged conductor. So we are bringing two charged conductors from one place, right. We charge A negatively, we charge B positively. That means we put electrons at on A and rip out electrons from B. Thus B becomes positive and A becomes negative. Now when these two things are connected with the help of a metal wire, now as you all know, A has excess of electrons, hence the electrons will move from A to B as shown in the diagram, okay. Until when does it move? This flow here, this flow of electrons continues till there is equal concentration of electrons in both the conductors, right. So what we conclude from all these examples? The inference is, from the above example, it is clear that the flow of electrons between two conductors joined by a metal wire can be maintained for a long time if it is somehow made possible to maintain an excess of electrons in one conductor. That means if we make excess of electrons in one conductor and we make deficiency of electrons in another conductor, okay, higher the deficiency and higher the excess of electrons, thus the longer the time the electrons will move, right, from the negative end to the positive end. This is done in an electric cell. In an electric cell, excess of electrons on one electrode, that is known as cathode, and the deficit of electrons on the other electrode, that is anode, are maintained for sufficiently long time by a chemical reaction within the cell. within the electrolyte, right. Thus an electric cell works as a source of electrons, and there is a continuous flow of electrons in the external circuit. External circuit means in the wire, right, connected with the cell in direction from cathode to anode. So this is how the electrons will move from one end to other end. So the things required for electrons to move from one end to other end, that means one substance should be negatively charged, the other substance should be positively charged, right, for a longer duration of flow, for the faster flow, right, and it can be maintained with the help of a chemical reaction. Now direction of flow of electric current, which you have studied, conventional and electric flow, which you have done. Okay, this can be compared with various things which we already know in our common experience, that if a body is released from a height, the body always moves from a higher level A to the lower level B near the earth surface, that is from a higher gravitational potential to the lower gravitational potential. That means the body is kept at a higher height will be having higher gravitational potential. So always the body will move from higher gravitational potential to the lower gravitational potential, that is from a height to the ground. Similarly, if two vessels containing water, here shown in the diagram, right, is connected in this fashion, and we allow the water to flow, then what will happen, the water always flows from a higher level to the lower level, or I can say higher pressure to the lower pressure, right, that is high to low. In the previous case also it was high to low, right. Now we can take another example also, where two bodies at different temperatures are connected, okay, as shown in this figure. Now here A is at higher temperature and B is at lower temperature. So where will the heat flow? The heat will flow from A to B, from A to B, that is from high to low. So whatever flow is there, heat, water or object, right, moving from a higher height to a lower height, so these all things are moving from a high to low, right. In a similar manner, charges also should move from high to low, right. So when two charged conductors are joined in a metal wire, the direction of flow of electrons is determined by a quantity called the electric potential. That means how fast will these electrons flow or move is decided by something called electric potential of a conductor. A conductor having excess of electrons is said to be at a negative or a lower potential, while having a deficiency of electrons, that is positive, is considered to be okay, is said to be at a higher potential. Okay, so in figure 9.24, a positively charged conductor having a deficiency of electrons or deficit of electrons, that is at a higher potential. A deficit of electrons means positive, right, is joined by a metal wire to a negatively charged conductor B having excess of electrons, that is at a lower potential. So the direction of the flow of electrons should be from conductor B to A, that is from a low potential to the higher potential. But if you remember, the direction of the current was taken in the opposite direction to the flow of electrons. So in keeping with the conventional flow from a higher to the lower level, the electric current is said to flow from a body at a higher potential to a lower potential. So that is another reason why the direction of the current is taken from positive to negative. Thus the direction of the flow of conventional current is opposite to the direction of the flow of electrons, right, which we had studied in our previous videos also. So this is the figure given to us. Okay, so what we can understand is a positively charged body is considered to be at a higher potential, considered, again I am telling, right, and the body which is charged negatively should be at a lower potential. So the flow of electrons should be from the lower potential to the higher potential, but the flow of current should be from a positively charged body, that is higher potential, to the negative charged body, which is lower potential. So I hope you have understood this, although we have discussed this in our previous videos also. Now let us go to the next topic, which says elementary idea about the work done in transferring charges through a conducting wire, that is potential difference V equals to W upon Q. Now when we were discussing this particular video, when we had started this particular video, we said that let a body be positively charged be connected with the uncharged body, or a body negatively charged be connected with the uncharged body, or a negative charged body might be connected with the positive charged body. Now we are discussing about how to make one body negative charge and how to make one body positive charge, and what are the energy spent or the work necessary to make this positive and negative, and what is that particular thing known as. So we know that like charges repel, isn't it, and unlike charges attract. So therefore to create an excess of electrons or deficiency of electrons, we need to do work, right? Okay. So either to make excess of electrons or deficiency of electrons, some work needs to be done, right, in moving these charges to make it positive and make it negative. Now when work is done, you all know that two things are involved, one is distance, the other is force, right. So we need to apply force to move one electron from one point to the other point. So the force between two charges is 0 when they are at infinite separation. Okay, thus quantitatively potential at a point is measured in terms of work done in bringing a charge q from infinity to that point. If w dash of work is done in bringing a charge q from infinity to that point, then the potential can be written as V equals to, where V is the symbol for potential, V is the symbol for potential and potential difference. Okay, potential and potential difference, which is equal to work done upon the charge. Okay, work done to move this particular charge, right. So let us try to understand more with the help of some diagrams. Let us consider one point here A, right, and there is one charge placed at an infinite distance from this point. Suppose I am bringing this charge from this point, from infinite, that is, to this particular point. Obviously work has to be done, right. Obviously we need to spend some energy, or we need to do some work in order to bring this charge from infinity to this particular point, right. So why is work done? Suppose this point A is positive and I am bringing one positive charge only. Now what will happen? This positive charge will try to repel this unit positive charge. So while this charge repels this particular charge, what happens? I need to apply one extra force to bring this positive charge to this particular point. So I need to do some work. But what if the charge is negative? Suppose it is not positive. Suppose this charge is negative. Now if this charge is negative, what will this charge, positive charge, do to this particular negative charge? Obviously this positive charge will attract, isn't it? It will attract. While attracting, this positive charge will do some work. So in both the scenario, either the charges are same or the charges are different, work is done. It does not matter who does the work, but work is being done to bring this charge from infinite or infinite to this particular point. Now this work done, right, in bringing this charge from infinite to this point is called the potential of this point, this particular point A. Now suppose, according to your book, suppose W dash amount of work is done, okay, to bring this particular charge Q, then the potential at this point V can be written as W dash upon Q, can be written as W dash upon. So this potential is a scalar quantity, and the SI unit of this potential should be the SI unit of work, which is joule, and the SI unit of charge, which is coulomb, which is better known as volt, whose symbol used is V, right. So the symbol for potential difference is V, and for volt is also V. So suppose we can write, suppose we want to write the potential of A is 50 volt. So we write potential of A is 50 volt. This V represents the potential of this particular point, and this 50 represents the magnitude, whereas this V represents the unit of the potential. Similarly, the potential difference between two conductors is measured in terms of work done in transferring the charge from one conductor to the other conductor through a metallic wire. So the potential difference between two conductors is equal to the work done in transferring a unit positive charge. It might be a negative also, right, but since it's easier for doing the calculations with the positive charge, so positive charge from one conductor to the another conductor, right. Suppose here we can consider one conductor, conductor A or conductor 1, the another one is B, right. This is conductor B, and suppose these two conductors are connected with the help of wire, right. So the wire is carrying one charge Q from A to B, right. So the potential difference between these 2 points, okay, is equal to the work done in moving this charge Q from one conductor to the another conductor, right. So I hope you are understanding this, and this is known as potential difference. So if work W is done in transferring a test charge Q from one conductor to another conductor, the potential difference between them can be considered as V1 minus V2. If V1 is the potential of the first conductor, V2 is the potential of the second conductor. So when we subtract the potentials, we shall get potential difference. So potential difference will be given by W upon Q. Potential difference is also a scalar quantity. Unit of potential difference from the relation V equals to Q upon W, where V is the potential difference, W is the work done, Q is the test charge which is being moved. Then unit of the potential difference will be unit of work upon unit of charge, which is joule upon coulomb, and can be also expressed as volt, right, abbreviated as V as before. Thus 1 volt equals to 1 joule per coulomb, per 1 coulomb. Okay, so this is the definition of potential difference of 1 volt. Potential difference between 2 points is said to be 1 volt if the work done in transferring 1 coulomb of charge from one point to the another point is 1 joule. So if you spend 1 joule of work in moving the charge from one point to the another point, and if the value of charge is 1 coulomb, then the potential difference between those 2 points is considered to be 1 volt. Now the next topic which we are discussing is the electrical resistance. So when current flows through a metallic wire, you can imagine the flow of current as the flow of water in a pipe, right. This particular wire or particular instrument, wherever the current is flowing, electrical gadget wherever the current is flowing, will offer some kind of obstructions to the flow of this current. These obstructions are called resistance. These obstructions are called resistance. Now where does it come from, etc., we have to learn. Thus we can define resistance as the obstructions offered to the flow of current by the wire. Okay, obstructions offered to the flow of current by the wire. Now let us understand what causes this obstruction or resistance. A metal wire has free electrons, as you all know, which moves in a random manner in the absence of any cell connected across it. That means in a given wire no current is flowing, because all these free electrons, as shown in this figure particular here, can move in any random direction. It is moving randomly, not in a given direction. So there is no current flowing in the wire. But if we provide one cell, okay, to this particular wire here, what happens? Cell will have a positive terminal and a negative terminal. So all the electrons here shown by a dot will be directed towards the positive terminal and will be going away from the negative terminal. Thus the electrons are drifted towards a particular direction. Thus we can say the current is flowing in the opposite direction, right? The current is flowing in the opposite direction. These directions get cancelled out, hence it becomes a scalar quantity, right? Now whenever these electrons are flowing, since we are discussing about the resistance, whenever these electrons are flowing, there are high possibility of collision between these electrons and these positive ions, or between any two randomly moving electrons, right? So these collisions create obstructions for their movement, thus resistance comes, right? Thus resistance comes. So let us go to the paragraph and see what does the paragraph wants to tell us, right? So when the ends of the wire are connected to a cell, the electron starts moving from the negative terminal of a cell to its positive terminal through the metal wire. During their movement, they collide with the fixed positive ions and other free electrons of wire, due to which their speed decreases and the direction of the motion changes. After each collision, they again accelerate towards the positive terminal. That means when they collide, they stop, they might be moved back, but still they are attracted towards the positive ion, so they start moving towards the they are attracted towards the positive terminal, so they start moving towards the positive terminal. And other free electrons of the wire, due to which their speed decreases and their direction of motion changes. After each collision, they again accelerate towards the positive terminal and suffer collisions with the other positive ions and free electrons again. So this process continues, right? As a result, the electrons do not move in bulk. That means if there was no collision, the electrons will be moving in bulk from one end to the other end, right, with increasing speed, but they don't do so, right? Rather they drift towards the positive terminal. That means they are colliding and then moving, again colliding, again moving, right? Thus the wire offers some resistance to the flow of electrons. That means here these collisions create slowing down of the movement of electrons, thus the current is obstructed, right? So figure 9.25b shows the drift of electrons in a wire. The electrons are shown by the dots and the positive ions are shown by the this particular symbol, okay, shown by this particular symbol. We have already seen this particular diagram. I hope you have understood this particular resistance and the cause of resistance. Now since we have studied three things, okay, remember we have studied three things, and these three things are: number 1 current, number 2 potential difference, and number 3 resistance. Remember capital R represents resistance. Now these three things are connected to each other with the help of a law known as Ohm's law. According to Ohm's law, if a current I flows through a wire when the potential difference across the ends of the wire is V, that means if the potential difference between these two here, let us take help of this particular figure. If the potential difference between these two terminals is V, and suppose the current flowing in this wire is I, right, such that the resistance offered by the whole wire, this wire and the whole wire, this is the zoomed portion, right, everything whatever happens here is happening everywhere in this particular wire, right, and the resistance offered by this wire is capital R. Now according to the Ohm's law, okay, all these three are related, and how they are related is resistance offered by the wire to the flow of electrons is the ratio of the potential difference across it to the current flowing in it. So resistance R can be written as potential difference across the wire, which was V, upon the current. Thus if we cross multiply, we are getting V equals to I into R, okay, and this is the mathematical form of Ohm's law. Regarding their definition etc., we shall do it in class 10 in detail, right. So resistance is also a scalar quantity. All of them, current, potential difference, resistance, all of these three physical quantities are scalar quantity. Unit of resistance again comes from the formula of resistance, which is R equals to V upon I. Okay, unit of resistance should be equal to unit of potential difference upon unit of current. Okay, what is the unit of potential difference? The unit of potential difference is volt. What's the unit of current? It is ampere. So volt by ampere, better known as ohm, whose symbol is this omega, right? The Greek alphabet omega. So 1 ohm can be written as 1 volt upon 1 ampere, right? So the definition of 1 ohm, like the definition of 1 volt, the definition of 1 ohm will be the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference across its end is 1 volt. That means suppose we have a cell of 1 volt. Okay, suppose we have a cell of 1 volt, positive terminal, negative terminal, 1 volt, and we connect them with the wire, right? If I amount of current is flowing through the wire and sorry, not I, if 1 ampere of current is flowing, okay, if 1 ampere of current is flowing through the wire, okay, then the resistance offered by this wire should be 1 ohm. Okay, I hope you have understood the definition of 1 ohm or simply ohm. Now factors affecting the resistance of a conductor, this has to be done in class 10 in detail. So briefly going through this particular statements or the factors. Number 1 is the material of the wire. Now as you see, there are different kinds of materials. Here the meaning of material means how many free electrons does that particular material have. The resistance of a wire depends upon the number of collisions which the electrons moving through it suffer, okay, while they are moving in the wire towards the positive terminal. In different materials, the concentration of electrons and the arrangement of atoms are different. Therefore, the resistance of the wires of the same length, same area of cross section, but of different materials will be different, right? So those who have more number of free electrons will be offering less resistance. Those who have less number of free electrons will be offering more resistance. Okay, good conductors have high concentration of electrons, so they have less resistance, whereas the bad conductors or insulators, they have high resistance. Now here they have mentioned, I was about to skip that, area, length, right? So these all things will be discussed in class 10. What is the relationship between area, length and all, okay, but simple discussion is given in class 9 also. Now the length of wire. So the length of wire, the number of collisions suffered by the moving electrons will be more if it has to travel a longer distance, right? So therefore a long wire will always offer big resistance or higher resistance because it increases the number of collisions. Now the area of cross section of the wire, as the area increases, then these free electrons which are moving will get more space to move, so less number of collisions, hence the resistance will be less. So in a thick wire, electrons get larger area of cross section to flow compared to the thin wire, so therefore it offers less resistance. So we can say resistance of wire is inversely proportional to the area, whereas the resistance of wire is directly proportional to the length of the wire. The fourth and the last factor which affects the resistance of the wire is the temperature of the wire. You must have noticed that when you use electrical appliances, it gets heated up, right? So the temperature of the appliance increases. So what happens to the resistance of that appliance? Let's see. So if the temperature of the wire increases, ions in it vibrate more violently, or the electrons starts moving randomly. As a result, the number of collisions increases, right? The number of collisions increases, and hence the resistance of the wire also increases. That is, the resistance of a wire is directly proportional to the increase in temperature, right? If the temperature increases, the resistance of the given wire also increases. So this much for this video. Thank you so much.